Hi students. So for last lesson, we have went through about how to use the periodic table to identify the number of protons, electrons, nucleons, and neutrons of an element. So in this case, this one is in chapter 8. Okay, so now let's move on. Let's do a quick recap. So in a periodic table, how do we find the number of protons, right? It's actually written over here in this key. So the key, right, just tell you what does each number represent or what does each symbol represent. So in this case, they say that this top number is called the proton number, and in simple words, it just means the number of protons. So for an atom is electrically neutral. So it means, right, it has no charge. So when it has no charge, the number of electrons will be equal to the number of protons. So in this case, it just means, right, the number of protons we have will be equal to the number of electrons we have. So for example, let's look at boron over here, this one. So in this case, right, boron has a proton number of 5. It means that it has 5 protons. So since it has 5 protons, it also means that it has 5 electrons, because every plus will be always accompanied with a minus. So the next one, relative atomic mass. In simple word, the word relative just means you need to compare with other elements. So the word atomic mass, it just means the mass of an atom. Mass of atom. So for the mass of atom, it is largely depends on the mass of the nucleus, because the mass of electron is very insignificant, very small, negligible. So in order to find out what is the mass of an relative mass of an atom or relative atomic mass, we need to take the number of protons plus the number of neutrons. So this is what it means. So don't worry, this nucleon number, if you're given a periodic table and you are given the element, you'll be able to know what are the nucleon number. You don't need to memorize it. Unless the question states that give you the number of neutrons and give you the number of protons, then you need to calculate what is the number of nucleons. So in order to find the number of neutrons, for example, boron, I'll take 11, which is the nucleon number, the relative atomic mass, this one. 11 minus 5 give me 6. So once I deduct the number of protons, it'll give me the number of neutrons. So this is simple mathematics. Let's move on. So let's look at this question 2, which is where we have left off. So in an atom, Y has 118 neutrons, 118, and 79 electrons. So let's highlight some keywords. So the word atom, right, it just means it is electrically neutral. So when something is electrically neutral, it means that the number of proton, the plus charge, is equals to the number of electrons, the negative charge. So that means every plus charge will be tagged along with a negative charge. So in this case, how many protons should it have? So based on this property, it will have 79 protons. So what is its nucleon number? So the word nucleon number or relative atomic mass, it means, right, the total number of neutrons plus protons. So since we have gathered the number of protons in the first part, we can just take 79 plus 118 give me 200. No, it's not 200. So you just use a calculator. So always bring a calculator during your science exam. So 18 plus 29 will be 97. So it'll be 197. So now lastly, hence identify element Y using the periodic table. So we know that element Y, it has a nucleon number of 197 and a proton number of 79. So by looking at the periodic table, you can tell that it is a 119, let's check for 119 and 79. So it's over here. It's the mass of, so this element Y is gold because it fits the criteria of 79 proton number and 197 nucleon number. So whenever you are given a proton number, you can just zoom in to find out what is the element. Because all element has unique proton number. So in this case, 79, you can just read accordingly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all the proton numbers always increase by 1 across the row. So once you reach 79, then there you go. It's the element of gold. So it is gold. So the next question, question 3. So question 3 states that these are the tables provided here, which shows the proton number, neutron number, and electron number of these 4 elements P, Q, R, S. So how many electrons are there in one atom of S? So in this case, we know that an atom electrically neutral. So when it's electrically neutral, it means that the number of protons is equal to the number of electrons. So P equals to E. So in this case, since we know that P is equals to 12, so E will be equals to 12. So E represents electrons. So what is the nuclear number of S? So the nuclear number of S, right, is basically nuclear number is P plus N. So in this case, it's 12 plus 12 equals to 24. Next, identify atom S, name it, and give its correct chemical symbol. So we know that it has a proton number of 12. P equals to 12. So you go back to the periodic table and you search which element has a proton number of 12. So in this case, right, if I'm not wrong, it will be magnesium. And the symbol will be Mg. So which atom has the greatest relative mass? So how to find it, right? It will be basically adding up the number of protons plus neutrons. So for S, right, is 24, which is what we have calculated. And for R will be 22, Q will be 23, and P will be 20. So that means S will have the greatest relative mass. Because So S has the greatest relative mass because it has the biggest nuclear number. Okay, so the question is quite straightforward. As long as you can understand these concepts. Okay, so for this question over here, we'll move on to the next lesson as we won't be learning isotope in this lesson. So question of the day today. So after you finish this video, there will be a pun also. Please don't fast forward. You can speed up the rate if you find it too slow, but please don't skip. Because to have a good learning habit, you need to understand what are the different key terms in the video so that when you revise, right, you'll be understanding what are the key terms and you understand what does it mean also. So let's do a good start to have some good learning habits. Read all the questions of the day and try to answer them after you watch finish this video. So if you can successfully answer them, that means that you have learned this lesson. So what is a molecule? This one is the first one that we'll be learning. And how to count the total number of atoms in a molecule. The next one, how to identify the different elements in a molecule. So this third questions over here is a recap from chapter 3, elements, compound, and mixture. Because in elements, compound, and mixture, under the compound, we have already learned how to identify the different elements in the molecule, which is to identify the different capital letters that you can see in a formula. So basically, this lesson will be zooming in on question 1 and 2, because these are something new for you. Let's start. So molecule, so this is on page 6 of your notes. Okay, so you can copy this on page 6 of your notes. So molecule is made up of 2 or more atoms chemically combined together. So the keyword here is 2 or more atoms chemically combined together. So the combined together must be there. Chemically must be there. 2 or more atoms must be there also. So let's take note. A molecule, right, can be an element also, for example, O2, or a compound like CO2. So it doesn't mean that molecule must be strictly made up of like 2 different elements. It can be the same element also. So it can have the same element, or it can consist of different elements. So how to know, right? You can just look at the chemical formula. O2, right, it has only 1 capital letter, so it means it has 1 element. So for CO2, it has 2 different capital letters. It means that it has 2 different elements. That's all. So let me show you the pictorial diagram of O2 and CO2. So this is how O2 look like, using a diagram to show you. This is O2, and this one is CO, carbon monoxide. This one is CO2, and this one is methane, CH4. Just a quick introduction. So to understand the chemical formula, this is just a quick recap. So when you see a formula CO2, it means that it consists of 1 carbon atom and 2 oxygen atom. So how scientists write it, right, is that they always write the number of the total number of atoms for the element behind the capital letter, as in behind the elements. For example, the 2 is written after O, and for C, right, it has 1 carbon, since there's no number here. So now no number there, it means, right, it has 1 atom. So 1 atom, 2 atoms, so there's a total of 3 atoms. So this is how you identify the number of atoms for each element. So the number 2 here represents 2 oxygen atoms, and the no number here represents, right, 1 carbon atom. So let's look at this chemical formula of sucrose, which is a type of sugar. Okay, so just for information, type of sugar. So in this one sucrose molecule, how many carbon atoms are there? There are 12. Look at this number. And how many hydrogen atoms are there? There are 22. And how many oxygen atoms are there? There are 11. So if I want to ask you the questions, how many different elements are there? So it will be 3 capital letters, C, H, and O. That means it has 3 different elements. Okay, now let's look at some example. So for ammonia, it has a chemical formula of NH3. So what does it mean? So first step, you need to identify what are the different elements in a compound first, or a molecule first. or element first. So in this case, step one, write it somewhere. First step, okay, let me write at the left side. First step, identify different elements. So if you found any space like around this node, you can write it down. So that at least when you go through this process, you understand, oh, I must do this step first, followed by the next step, just like math, step by step. So identify the different elements. After that, you can count the number of atoms for each element if they ask you. And after that, if they ask you for the total number of atoms, right, then you need to add them up together. So in this case, they say list the type and number of atoms in one molecule. So this one is considered one molecule. So in one molecule, right, there's one nitrogen atom, as there's no number here, and there's 3 hydrogen atom. So that's why it's 1 nitrogen atom, 3 hydrogen atom. So how many different type of elements, right? There are 2. So this is just an extension question. So for iodine, it has a chemical formula of I2. So what does it mean? It means that it has 2 iodine atoms. So in this case, right, let me extend the question a bit. Is this an element or is it a compound? Okay, so if you understand the general idea of an element, it means, right, it has only one capital letter. So in this case, right, since we see only one capital letter, it means that this one is an element, not a compound. Compound is made up of 2 or more elements chemically combined together. So in this case, this one is an element. It's an element because there's only one type of element. The next one will be methane, CH4. It means 1 carbon atom, 4 hydrogen atom. And for sulfuric acid, it's H2SO4. It means that it has 2 hydrogen atom, 1 sulfur atom, and 4 oxygen atom. So the last column over here is a molecular diagram to show the combination of how the atoms are being arranged. So for ammonia, the white color one represents the hydrogen atoms, and the blue in the middle represents nitrogen atoms. So the specific color, you don't need to be bothered about it. We just basically use different colors, right, to show you that they are different elements, that's all. So different colors just means different element. You don't need to make it so specifically in your test or exam. And most we want you to do is just to shade, or maybe just don't shade for some, to differentiate between the elements. So for iodine, it looks like this. 2 purple atoms because they are of the same element. And for methane, it looks like this, CH4. C is in the middle and is combined by or bonded with 4 hydrogen atoms. So conclusion, what is a molecule? A molecule is basically made up of 2 or more atoms chemically combined together. So it's 2 or more atoms must be there. Because when you have only 1 atom, it cannot be a molecule. It must be 2 or more, at least 2. Chemically combined together. These are the 2 keywords. 2 important keywords. You miss any of them, you won't be awarded the 1 mark. So normally definition question, so it's called definition question. They ask you what is a molecule, right? It's always 1 mark. So if you miss any keywords, you got 0. The next step, how to count the total atoms of a molecule, right? Let's go back. In this case, you just need to count the numbers. So in this case, sulfuric acid, the last row, H2SO4. So it means, right, when you want to calculate the total number, it will be 2 plus 1 plus 4, which is 7. So just add up all the numbers that you can see in the compound. So it's just a starter. It's just something simple. And lastly, how to identify the different elements in a molecule? Basically, we look at the number of different capital letters. Yep, so just a quick recap. So for your science homework, please do page 87 to 90. You can refer to your textbook and notes. So let's pick up good learning habits. When I give you some work, please do it and try it. So at least when we go through the questions, right, at least you know what are the key points that you need to take note of, or like what are the things that you really don't know. That's why you want to like listen attentively. And it also doesn't mean that if you know you don't listen attentively, you still have to listen attentively. Just in case I like highlight any key points. So please try page 87 to 90. Try your best. Some of the questions, right, I will like break it down for you so that you can understand what does it mean. So you can refer to your textbook and notes while you do these questions. So don't be afraid to try and attempt it. It's okay to be uncomfortable now. Rather than you face the exam, you see so many like unfamiliar questions and you start to be afraid or panic. That will be too late. So now is the time for you to be afraid, to be worried, or like to be unfamiliar with the questions. It's alright, because if you are new to the questions, just give it a try first and try to understand the different keywords. So once you have overcome this fear of like doing unfamiliar questions, then when exams comes, right, mostly the question might be familiar to you because you have already like tried this before and internalized in your head. So a science pun. Why is the molecule of oxygen always worried? Because it is always uh-oh. Okay, some of you get it, some of you need a little bit more time. Okay, so I hope you will follow the advice, pick up good learning habits, and I can promise you that the next test or exam, you will definitely improve. Okay, so let's move on to the workbook. Page 87. So I need to highlight to you what is a ball and stick model. This one. So this ball and stick model, right, is basically what we have seen earlier on, which is the molecular diagram. Look like this one. So they say, right, the ball and stick model of an atom using ball of different masses. Which of the following we expect to see in Peter's model of an atom? So now they are talking about atoms. So you need to know in an atom, right, what are the different subparticles and how to use the different ball of different mass, right, to represent it. So you need to think about it. So ball and stick diagram is what we see earlier, the molecular diagram. So NH3, right, you need to go and decide which of the statement is true. So this is NH3. You can always refer to your notes. So mostly, right, all your notes, right, contains all the answers, right, to your workbook. So the workbook is just an application on how you apply the things you learn to the workbook. So once you can apply it, this knowledge should be yours.